Hello friends, we welcome you all on BYJU'S exam prep. In this session guys, me and Dheeraj sir will be testing your formulas, or we can say that we'll be revising your formulas. Okay, so one way of revising the formula is the Ghisa-Pita method that you all do every time is revising all the formulas. Instead, what we have done the reverse engineering here. We will be putting some MCQs in the form of question, and those questions answer you have to give, and the answer will be related to a formula or a fact or a assumption which is used for the derivation. Okay, so those questions are such handpicked questions where answer will be given by you by using the formula or knowing the formula or revising the formula or by a fact or by some assumptions that are used in the derivation. So your formula plus derivation assumptions plus facts plus concepts all will be judged in those questions. That is why it is not formula revision, it is formula memory test through a quiz, through some MCQ questions. Before we go further to the questions one by one, let us go directly to 250 kilometers away from my home in Delhi to Hisar and ask Dheeraj sir कि वहां का मौसम का क्या हाल है.
Sir, I feel now we are doing weather reporting. So now weather have been changed. Now winter season is coming. So guys, this series is unique in many manners because I know when we were going for the questions, every time some of the students were saying, Ki, sir, what is the formula? I forget. So keeping that into the mind, last year also we come up at that time for such a series because it will give you an idea that what kind of mistakes you can do in remembering the formula. Like I know whenever the students are going to give exam, they are sharing their experiences. So sometimes whenever they are telling, we get to know what kind of mistakes they have done. So keeping that into mind only we have made the question. Okay. So that is why it is going to help you in many ways. It is just not checking of the formula. It is telling you that what kind of mistake you can do so that you can avoid those things. So this is going to be a wonderful one. So sir, over to you. So start with the questions now.
Okay. So guys, this is the formula memory test, and let me tell you guys, if you want to enroll in BYJU'S exam prep, then on 29th October, that is tomorrow, there is a scholarship test from 9 a.m. to 9 p.m. You can give this test and get up to 90% discount, 90%, 80%, 70% depending upon your score. So this is free of cost, the scholarship test. And guys, if you are preparing for 2025, then the blueprint, the complete path guys, for GATE 2025 that I'll be telling you on a free workshop. That is a special workshop, guys. First time for 2025 by me. Already sir has taken. That will be on Wednesday at 7:30 p.m. on app. Okay. So limited seats, guys. You can enroll here. This is the free workshop for 2025. Guys, MMC is there for all branches, civil, mechanical, all branches are there. What is MMC? That guys, we are conducting some free mock tests exactly as GATE pattern. Like for civil, it is from 20th October to 3rd November, it is mechanics, SOM, structure, steel, concrete design. Then 4th, anytime from 20th October to 3rd November, anytime you can give this test. 65 questions of these subjects, 100 marks in 180 minutes. And the results will be announced on 4th November. Anytime between 20th October to 3 November, you can give this test. And winners will be getting the heavy discounts on the test series. Similarly, mechanical students can give their subjects in this duration. This is free of cost. Guys, tomorrow, I guess at 10:30 a.m. Okay, tomorrow, that is Sunday ka funda. I have uploaded a shot 3 days before that how the bridge has been collapsed. Now the detailed analysis, the remedies, the preventions, and how to repair this. This is in my hometown. Okay, how to repair this, that I'll be telling you tomorrow. Okay, so see you here, guys, tomorrow in the Sunday ka funda. Okay, now going further, guys. This is my Telegram group, Civil by Abhinav sir and Mechanical by Dheeraj sir. Let us go with the test. Everyone, guys, please let me know. Are you ready, guys? I'll be doing some questions. Okay, I'll be doing some questions. Then Dheeraj sir will be coming. Then again I'll be coming. Then Dheeraj sir will be coming. This will be the flow of our session. First I'll be coming. Then Dheeraj sir. Then again I'll be coming. Then Dheeraj sir. And this will be the flow. Okay. So, guys, this is the question. Which method is applicable for finding the deflection at point A? This is A, guys. This is A. Tell me answers on the comment box. From this, you got to know that which methods are suitable in which condition. Okay? Yes, Papa Ka Ghoda, what a name. 3 Arvind, Raghu, Anwar. Movement area method. Yes, guys. Principle of superposition. Kya superposition? Only one load is there. What you will add. Okay. So this is, guys. No. Yeah. Vinisha, good. Vinisha, how is your health now? How is your health now? Sir was telling about your health. So, guys, it is movement area method. Now, let me tell you, guys, movement area method gives theta difference of slope. Theta B minus theta A is equal to area of M by EI diagram between A and B. Okay. So, guys, in slope and deflection, we want slope. We don't want difference of slope. Similarly, it gives deflection of any point with respect to tangent at A is equal to area of M by EI diagram into distance about that point where we are finding deflection. But guys, we want theta. We don't want difference of theta. So when one theta is zero, either theta B or theta A, whatever, when another theta is zero, then it is useful. Like in cantilevers, theta at the fixed end is zero. So this can be applied. Okay, it's like simply supported beams, symmetrical simply supported beams. So in symmetrical simply supported beams, if it is simply supported symmetrical, then also, guys, the theta deflected curve will be like this and slope at the center will be zero. So one of the slope will be zero, then we can use this. Similarly, guys, here deflection of A with respect to tangent at C. In cantilever, what happens? So, okay, suppose this is the load, even if it is non-prismatic, like this. Now, theta, suppose this is P point, this is Q point. Now, deflection of P with respect to Q. It is actually deflection of P, because the deflection of P with respect to tangent at Q. Tangent at Q is like this. So, with respect to this is deflection of P point with respect to tangent at Q. And that is actually delta P. Okay, so it is used where zero slope is there. And in cantilevers and symmetrical simply supported beams. Now, guys, of course, the question cannot be like this. Now you can say, sir, where the double integration method is used? Where the double integration method is used, where a single bending moment equation can be written for the whole beam. Where a single bending moment equation can be written for the whole beam. Because what is double integration? What is double integration? d2y by dx2 is equal to m by ei, or let me put it here ei and here m. Now integrating this is ei dy by dx, that is slope. Then again integrating ei dy by dx, ei y is deflection. But here it is m na. If there is a beam where different part have different bending moment equation, we cannot use. Okay, we cannot use this. Then which m we will write? So double integration method is used where it is beam is prismatic, so there is single ei. If some part is ei, some part is 2 ei, then here if I have to write ei or 2 ei, what I don't know. So double integration method is used where it is a prismatic beam. So ei is constant, either we write ei, 2 ei, but for the whole beam it is that, and a bending moment equation is such that it is applicable for the whole beam, like this. P. So now at any x distance from here, the bending moment is px. That is valid here also, here also, here also, here also. For this, double integration method is used if it is prismatic. Now, Maclaurin's method is used where different parts having different bending moment equation. It is improvement of double integration. Moment area I told. Principle of superposition means a beam can be written as, beam A can be written as combination of two beams, such that these two combination result is all the standard result, or you can find out from any of the methods. Superposition means one beam is written as the combination of two beams, and the combination of two beams individually you can find the result either by any method or some standard results. Now, guys, when you don't know anything, then the BAP of all methods, where it is applicable everywhere, whether it is internal hinge, whether it is non-prismatic, non-symmetrical, whether it is beam, frame, arches, anything, that is strain energy method. Okay, that can be applied anywhere. Okay, so this is a summary of which method can be used where. Now, guys, let me move to the next question, guys. Come on. Tell me the answers on the comment box, guys. Keep sharing. Okay, hit the like button, guys. Hit the like button. Yes, you can watch my strain energy method or Dheeraj sir strain energy method as well. Now, guys, according to Euler's, the PCR is equal to n square pi square EI minimum upon L effective square. First of all, guys, you will say what, how n comes here. Guys, actually na, you study this, only this formula. Pi square E, you only study this formula. Which, what you study? Pi square E I minimum upon L effective ka square. You only study this. Why? Because for your case, n is always 1. But guys, suppose the column is like this. Then n can be 2, na? Buckling loops can be 2. Okay, in our case, only there are 2 supports, either here or here. So n is 1. So we say this. Otherwise, the formula can be this also. So this case also n is equal to 1. Only one loop. Only one. L effective is the distance of 0 bending moment or distance of 2 contraflexion. Okay, I minimum y. If I say the cross section of this na, suppose it is rectangular, then I can be about this also, this also. I can be about xx also, I can be about yy also. So of course, guys, I can buckle like this also, I can buckle like this also. I can buckle like this also. I'm again saying I can buckle like this also, I can buckle like this also. So I will take minimum na. About which axis? Suppose I can buckle like this at 60 kilonewton load. I can buckle like this at 70 kilonewton. So my shamta, my capacity is 60 na. I cannot take risk of 70. In this direction I can buckle in 60. In this direction I can buckle in 70. So my capacity is 60 na. In 60 I can buckle like this. Okay. So I take I minimum. Now in this case L effective is L by root 2. So here L effective is L by root 2. So it is pi square EI L by root 2 whole square. So that will go over here. It will be C option. Yes. Devan's got it, C. So Chandigarh, remember. Okay, Rushikesh, welcome, Rushikesh. Yes, I got it. Okay, keep sharing, guys. Enjoying. Come on. Okay, this question. The given figure below section of wood beam. This is wood. Okay. And this is steel. This is steel. This is steel. Now what is asked? What is asked? क्या पूछा है, कहाँ गया इंग्लिश? The second moment of area of the fleece beam about the x-axis. Okay. The second moment of area. Second moment of area means this is na r square dA. That is, they are asking I. Okay. Second moment, r square, second moment of area dA. So for this na, for wood, it is BD cube by 12. For steel, guys, if I convert it wood, it is 2T na, so it is 2MT. Steel is 2T na. Steel is 2T, blue is steel. If I convert it equivalent to wood is weaker material, so larger wood is required. How much larger? M times. M is Young's modulus of steel upon Young's modulus of wood. M is the ratio of Young's modulus of steel by Young's modulus of wood. So now the B becomes 2MT if I'm converting it to wood only. B, D is same upon 12. This is when I consider everything into wood. Anything is matching. 2MT into D cube by 12. C. Now one more thing, guys. If I convert everything in steel, so this is also one answer can be steel also. It can be MSQ also. Like BD cube by 12 for steel, it is B is this B into D cube by 12 plus this is B now for steel. If I replace steel, this is B of wood. This is B of wood. If I replace into B of steel, width of steel, steel lesser required, steel is stronger. So B by M. So now it is width is B by M into D cube by 12. But no answer is matching. So it can be MSQ also. If I do like this, it can be MSQ. So this is C option. C and D. No. BD cube by 12. 2M No, and not is no, it is not there, na. 2m cube is not there, na. Only 1m. Only 1m. Yes, Mohit. Excellent. Guys, are you enjoying this? Are you enjoying this? Any doubt you can ask me. Are interesting questions by me and Dheeraj sir for all of you. If a wire of 10 mm diameter is bent about a drum of radius 4 meter, then find out the maximum bending stress. Okay, this is a wire of my mic. This is bent in the drum. Okay, what is the stress here? Now, in this formula, now, what you have to do, you know the flexure formula. The flexure formula is sigma by y is equal to m by I by E by R. M is not known, na, but radius is known. The radius is 4 meter. It is bent in a drum of 4 meter. So radius is 4 meter. So sigma is equal to E by R into Y. It is maximum stress. So sigma max is equal to E by R into Y max. Okay, E by R into Y max. Which option? B option. What is Y? What is R? R is 4 meters. And Y, this is wire of 10 mm diameter, na? Wire of 10 mm diameter. So Y max is this. Y max is 10 mm. Sorry, diameter is 10. So from neutral axis is 5 mm. 5 into 10 ki power minus 3 meter. This is Y max. E you can put whatever given. Okay. Are somebody tell me, are you enjoying or not here? Are you getting these type of questions? Revising the formulas plus concepts plus the derivations which are used in the, or assumptions that are used in the derivation. Are you enjoying? Come on, yeah, give me yes or give me yes or no. 3 questions are done. Okay, this one, everyone, come on, I can derive this. I'm not remembering it exactly. I can derive this in 2 minutes. Let me see in my copy. शर्माता नहीं हूं ना भाई भाई. देखो भाई, आपके पास प्रिंसिपल स्ट्रेन की वैल्यू दे रखी है. तो एप्सिलॉन प्रिंसिपल स्ट्रेन 1 इज इक्वल टू द पॉइजन चैप्टर. यार, द पॉइजन चैप्टर इज सिग्मा 1 by E minus mu sigma 2 by E. Similarly, epsilon 2 is sigma 2 by E minus mu sigma 1 by E. Now, if you do cross engineering or reverse engineering, you want to find sigma 1. Okay. So, from these two equations, this is the complete derivation I am doing. This is E upon 1 minus mu square epsilon 1 plus mu epsilon 2. And sigma 2 from here is E upon 1 minus mu square epsilon 2 plus mu epsilon 1. So this can, sigma 1 is asked. E upon 1 minus mu square 1 minus mu epsilon 1 plus mu epsilon 2. That is C option. That is C option. Okay. Guys, this, how many? Okay, this is the last question by me. Then Dheeraj sir will be coming. Then again I will be coming. Okay, D to 2D. From diameter D to 2D. Okay. So delta is how much? 4PL pi D1 D2 into E. So 4PL pi 2D square into E is equal to 2PL pi D square into E. 2PL pi D square into E. That is B option. What is the D equivalent? If the diameter is D1 and D2, if the diameter is D1 and D2, I want to convert this in that diameter which has same deflection when applied same load P, same length, same material as of this. So D equivalent is under root D1, D2. That is geometric mean. If you take this diameter, then the deflection of this tapered bar and this uniform section is same. Okay, if somebody take arithmetic mean, his deflection will be lesser because arithmetic mean is greater than geometric mean. So if you take answer is correct, answer is coming from geometric mean. If you take arithmetic mean, diameter will be bigger, but diameter comes PL by AE. Area comes in denominator, na? So deflection will be lesser than the actual deflection. Actual deflection comes from geometric mean. Okay. Now I welcome my opening partner in cricket team. When we play BYJU'S match, it is civil mechanical versus electrical electronics computer science. So my opening batsman partner, Dheeraj sir, to take
Uh,
carry on. Then
yes,
Dheeraj sir
sir.
will take some questions, then I will be coming, then again Dheeraj sir will be coming.
Yes, guys. So this is a question from principal stresses. I feel just by looking at it, you guys can answer it. जख्मी आत्मा, गुड मॉर्निंग. कौन सा मॉर्निंग चल रहा है ये? चलिए. So guys, this is the relation between sigma theta and tau theta, where this is the state of stress at a point is given. Sigma xx, sigma yy, tau xy is the applied loading, and on this inclined plane, sigma theta and tau theta are the induced stresses. So they are asking which relation out of these four is correct. You can see the first relation is d sigma theta by d theta is tau theta. Second is d tau theta by d theta is sigma theta. Third one is d sigma theta by d theta is minus 2 tau theta. Fourth one is d sigma theta by d theta is minus tau theta. Okay, so Zakmi Atma and Papa Ka Ghoda have said the answer to be C. What about others? बाकी लोग भी बताइए. Then we move on to the solution. Very good, Vineet. बहुत ही बढ़िया, शानदार, बहुत ही बढ़िया. Yes, Hari, what will be the answer? So the answer is B or C. अभी भी सोच लो भाई. अभी भी सोच लो. Majority of you have said the C answer. So let me tell you the answer. If you remember, you derive the sigma theta as equals to sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 into cos 2 theta, and you are writing it plus tau xy sine 2 theta. This is the expression for sigma theta. So if we are going to differentiate this d sigma theta by d theta, so my dear, if you will differentiate this term, there is no sine cos theta component, it is 0. Then my dear, when you will go for differentiation of this, sigma xx minus sigma yy by 2 is constant. For cos 2 theta, it will be minus 2 sine 2 theta. Okay, then you will be having plus tau xy. Then sine 2 theta will be 2 cos 2 theta. So my dear, if you will take here, this is minus 2 sine 2 theta, this is plus 2. So if you will be writing it d sigma theta by d theta, it is equals to, if we are taking 2 as common, minus 2 as common, then you would be writing it as sigma xx minus sigma yy by 2 into sine 2 theta, then minus tau xy into cos 2 theta. So if you can feel it, this is nothing but tau theta. So my dear, can we write d sigma theta by d theta is equals to minus 2 of tau theta? This is a wonderful relation which can come in exam. So the answer for this is going to be B. Okay, is it clear for everyone? Zakmi Atma, Vineet, sabhi ko aa gaya? Is it clear for everyone? Please tell me that. Is it clear for everyone? Yes, Papa Ka Ghoda. Is it clear for everyone? Devanand, Anwar. So the answer for this is going to be B. Okay, is it clear? So guys, the next question is, yes, Zakmi Atma, good evening it is. So next question is this one. This one. So if you see this question, this is saying if a conical bar is subjected to self-weight, what should be the deformation? So if you remember, whenever we are going to have the conical bar, so you need to find out that which derivation, which result will be correct, where rho is nothing but the density. Okay, G, you know that it is acceleration due to gravity. L is the length, and E is the Young's modulus. Yes, so Chandan is saying C, Papa Ghoda is saying C. No, Mohit, it is negative, na? It is negative, na, because this minus 2 is coming outside. So how it is positive? It is minus 2 times of tau theta. So that is why whenever you are looking for the principal plane, you are putting tau theta also equals to 0. Is it clear? So that is the reason. Okay. So this was the question now we were looking for. So my dear, whenever we are looking for this question, the answer is going to be rho g L square upon 6c. So I feel, you know, whenever we go for the derivation, if we are going to have a prismatic bar, and my dear, in this prismatic bar, if we are going to find out the deformation because of self-weight, then delta is coming out to be rho g L square upon 2e.
which can also be written as WL upon 2AE. Okay. So if it would be this question, then this would be MSQ, and obviously A and D would be correct. But this time they are asking about the conical bar. So when you would be performing the same question for this conical bar, my dear, then the answer will be coming out to be rho g L square upon 6C. If you want to see what is going to happen on this small bar, which I have just hatched down, on this, the weight of this green hatched part will be acting. So if I am going to consider this small white bar, which is having a radius of r, let us say small r is the radius. Okay. So on this, the weight of this ABC part is acting. So if on this the weight of ABC part is acting, so I can say Pxx is equals to weight. What is weight? Weight is m into g. What is mg? We can consider this length to be x. Total length is L. So my dear, we can write mg is the weight, then m can be written as rho into volume into g. Volume is not area into length because it is cone. For cone, when we write volume is 1/3 pi r square x. Okay, into g. So my dear, you know, for a small bar of length dx, if I want to find out the small deformation, it will be PL upon A. P is Pxx because it is depending on x. Then you would be having dx is the length of this member. Area is pi r square for this. E is the Young's modulus. So when you will be putting this value, small deformation after integration will become total. And for that you will put rho into 1/3 pi r square x dx divided by g is also there. Then you will be having pi r square into E. Pi r square will get cancelled out and you will be getting rho g L square upon 6C. So my dear, for this, the answer is going to be C, which you have ticked already. So this is correct answer. Then my dear, this is the question from theories of failures. And here the question is saying, Mohit Sharma. Okay, for Mohit Sharma, I am writing the expression for tau theta. Whatever the, just give me a second. Mohit Sharma, this was the question. For this stress, whatever I have made this direction, for this direction and for this given loading condition, tau theta is coming out to be sigma xx minus sigma yy by 2 sine 2 theta minus tau xy cos 2 theta. Actually, that always depends at what direction you have taken. I have taken tau theta in downward direction. So it also depends on the direction which we are taking. Okay. So this is the exact expression for tau theta. This was for Mohit Sharma. Now I am coming back to my question. This was my question. Yes. So in this question, my dear, this question is saying find out the distortion energy for the given state of stress. This is 3D state of stress given to us and the matrix is given. And you can see these are the formula mentioned, sigma 1, sigma 2, UD. So let us see how many of you are able to give the right answer. Just look at it. I have given this stress matrix. So you need to tell which of the formulas will be used if I want to find out the distortion energy, and this is MSQ. So if for this given data you need to find out the distortion energy, what are the formulas you would be using? So D will be answer. Okay, fine. Papa Goda is also saying D. Chandan is also saying D. Okay. Fine. What about others? Vineet is saying D. Jakmi Atma is saying D. थोड़ा सा तो देख लो भाई लोगों, D कैसे बोल रहे हो यार आप लोग हैं? भैया, if you remember, the total strain energy per unit volume is derived as 1/2E sigma 1 square, sigma 2 square, sigma 3 square minus 2 mu sigma 1 sigma 2 sigma 2 sigma 3 plus sigma 3 sigma 1. That is definitely correct, my dear. But distortion energy is not that.
distortion energy is U minus volumetric strain energy. It is 1 plus mu upon 3E into sigma 1 square plus sigma 2 square plus sigma 3 square minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 1 sigma 3. So my dear, obviously this formula will be used. C is correct. But as I said, this is MSQ. So my dear, you need to see one thing here, that if you see this formula, this stress distribution, this is the 3D state of stress. For 3D state of stress, you can see in this Z direction, there is no shear. So can I say this 20 is the direct value of sigma 3? Can I say sigma 3 is directly 20? Can I say sigma 3 is directly 20? Can I say sigma 3 is directly 20? Yes. And my dear, if sigma 3 is directly 20, from where you will get sigma 1 and sigma 2? For sigma 1 and sigma 2, you would be considering this 2 by 2 matrix. For that, you need to apply this formula as well. So as it is MSQ, the answer will be A and C. So first of all, A will help you to find out the principal stresses. Then C will help you to find out the distortion energy. So if it is MSQ, both will be the answer. So I have checked 2 questions at the same time for you. Yes, very good, Hari. So you guys are doing nicely, but thoda sa formula bhool rahe ho, and that is why we have kept this session. So I feel everybody is getting it. We are moving to the next question. Moving to the next question. Any doubt in this? Please ask. अरे भाई पार्थ, बार्क का एग्जाम पैटर्न ये फर्स्ट टाइम ही हो रहा है, ऐसा कोई एग्जाम हुआ नहीं है. आई ट्राइड सर्चिंग अ लॉट फॉर इट. तो सभी लोग अपने अंदाजे से ही बता पा रहे हैं, बिकॉज दैट इज नॉट हैपेंड बिफोर. तो एग्जैक्टली नहीं कहा जा सकता. आइडिया के लिए आई विल टेक ए सेशन समडे. ओके, सो मूविंग फर्दर, लेट अस सी द नेक्स्ट क्वेश्चन. दिस इज फॉर द shear stresses. To find out maximum shear stress and shear stress at any fiber for a circular cross section, and let us say this is the case that a beam is okay. Let me make it. Let us say we are talking about shear stresses in beams and circular cross section is mentioned. So let us say this is the loading also mentioned, so that you do not get confused that they are asking about shear stresses in the beams or they are asking about the shaft. So this loading is also mentioned, let us say. Then you need to answer about this. They are asking which formulas are used, and they are asking 2 things. One is the maximum shear, other is the shear stress at any fiber. So this is also MSQ. More than one options can be correct. Let us see how many of you will give the right answer for this. Yes. So Papa Ghoda is saying A. Okay, B is also coming. So if it is MSQ, what are the options correct? Parth is saying A and C. Then A and B. Okay. Just look at it. Which formulas are used? Hari is saying A. Okay, Akash Kumar Yadav is saying AB. So my dear, first of all, I would like to say that yes, shear stress at any fiber is given by SAY bar divided by INAB. So this is the shear stress at any fiber. So I asked at any fiber, yes. So this is going to be the answer. Then I also asked the maximum shear stress. Then to find out maximum shear stress, we are using tau max is equals to K times of tau average. And you all know that the K value is going to be 3 by 2 for rectangular section, and it is 4 by 3 for circular section. So answer is B. That is also correct. Then my dear, I asked which formulas will be used to calculate them. For that, you also need to have the value of tau average. So tau average is nothing but 4s by pi d square. Why? Because tau average is shear force but a shear area. So A, B, C are the answer. That is how the MSQ are making you confused. This is not the answer because this is the shear stress formula for the case of pure torsion, and here loading was not torsion. That's why D is not correct. Only A, B, C are correct. So can you feel it that we are doing 2 things? One is formulas are revised, and second is MSQ, how you need to deal with it. So both the things we are doing it right now. Moving further, guys. Okay, one more question, then Abhinav sir would be joining. Okay, let us take a easy question. Now, this is a wonderful question. Okay, easy and wonderful. This time it is not MSQ, it is MCQ. Only one option is correct. So they are saying that if maximum shear stress in a shaft is 100 MPa, whose diameter is 50 mm, find out the shear stress at a fiber with radius 30 mm. So you need to tell which formula will be used. Tau max is T by ZP. Second is tau by R, tau max by R. Third is tau max G theta R by L, tau max EY by R. So this is MCQ, only one option is correct. So Papa ka Ghoda, Vineet, Hari, Mohit, Atul, and guys, those who are preparing for BEL exam, I am telling you, soon I will be coming up with a mini mock test for BEL in the next week, because many students were asking. Okay. So after, like, you know, engineering mathematics is also going on. So after matrix, I will be starting differential equation. Okay, so Hari is saying B is the answer. Okay. सोच समझ कर बोलिएगा भाई, आकाश भी B बोल रहे हैं. हाँ, obviously R will be D by 2. R is radius. So my dear, you just see what is the data given. This is the maximum shear stress. So we are knowing that tau max is 100. Diameter is 50 mm. Okay. So, sorry, it is radius. Radius is 50 mm. So radius is 50 mm. It means R is 50. Then they are saying find out the shear stress at a fiber with radius of 30 mm. So if I want to find out shear stress at this radius, when shear stress at this radius is given to me, because if you are going to make the shear stress distribution on a shaft, it is coming like this. This is the shear stress distribution. You know, it is 0 at center and linearly varying, and maximum at the outer fiber. So what would be the answer? Yes, Manish is saying B, Surendra is saying B, Mohit is saying C. So guys, the answer is going to be C, because when we are talking about T by ZP, for that you need T. T is not given to us. So whenever we are aware of the maximum shear stress and maximum radius, then you need to put this and you will be getting this. So this is the straight away formula. Tau would be coming as tau max by R into R, because these three things are given to us. Is it clear? Is it clear, guys? Everybody got it? So now Abhinav sir would be joining for next questions. Then I am left with 2 to 3 more questions. Okay.
Okay. So guys, the next question is on your screen. The question is, for the given loading condition, find out the thermal stress. Okay. These are the two fixed ends. Here is a bar with coefficient of thermal expansion alpha, cross-section area A, Young's modulus is E, length is L, and then it is attached to a spring and then again fixed. So what is the thermal stress here? Okay. So what you can do, you can make a free body diagram. Okay. I'm just telling you the steps for the derivation. In free body diagram, guys, when temperature is increased, okay, it wants to increase. So from spring, the force will be here, Fs. And the same force, it wants to increase. It wants to increase. And the same force, when it wants to increase, it will be pushing spring inward. That is Fs. And this Fs is equal to sigma into area. Force is sigma into area. That sigma we want to find out. Now delta of this plus delta of spring, net delta is equal to 0. Okay, because it is both sides fixed. If this is increasing, this will be compressed by same amount. From this, guys, you will be getting the expression as this. What is KB? Guys, what is the bar? If I apply P force, what is the delta? PL by A. So if I assume it to be spring, K bar, okay, K of bar, if I assume it to be spring, then K is P by delta. K is P by delta. What is P by delta? A by L. So that is actually A by L. Now suppose from this expression, guys, you will get this answer. You will get this answer. I'm not going into that. Suppose I'm a student in exam And in exam, I don't know how to solve this. I'm not knowing this concept, or that is not coming in my mind. Now, what Abhinav Negi will be doing in this case? Just see the jugaad. And this jugaad, this trick, this technique will be helping in many of the questions of strength of material. Many of the questions, guys. I'll give you example. Suppose I don't know this, but I know that when the condition is like this, in that case, the stress is E alpha delta T. This I know. In this case, stress is E alpha delta T. Suppose K spring is infinite. Suppose K of spring is infinite. K infinite means stiffness infinite means K is P by delta. K is P by delta. So stiffness infinite means delta is 0. Delta 0 means it is fixed. If I'm saying that a spring is of K infinite, then it means fixed support. This can come in GATE exam, that they will make a spring of infinite stiffness and actually that is fixed. You have to take care of that. So in any of these options, if I put K spring as infinite, then this becomes a fixed support, then this becomes this quotient, the answer should be E alpha delta T. By putting K spring infinite. Here, if I'm putting infinite, sigma is infinite. But actually, when I put K infinite, this is this condition, so answer should be this. Here also K infinite, it is becoming 0. Here also, if I K spring is infinite, sorry, K spring has to be infinite. If if this is infinite, guys, this it becomes 0. But here, if K spring infinite, so K spring infinite, this term becomes 0. So 1 plus 0 is 1. So answer becomes E alpha delta T. So from this trick also the C is the answer. Have you understood what I want to say? Have you understood the trick? And this trick can be used anywhere, yaar. Let me tell you how this trick can be used in other questions also. Let me take a rough page. Let me take this page. Guys, what is the deflection of this when length is L, E, I and P? What is the deflection at the free end? Delta is equal to PL cube by 3EI. Okay. Now suppose it is length is L, but it is 2I. E. Okay, E. What is the deflection? PL cube by 3E into 2I, 6EI. But what if the question becomes for some length it is I, for some length it is 2I. Total length is L. Okay, E. Then here we have to use certain methods. But what Abhinav Negi will be doing, my brain will be doing, that this spring is stronger than this and weaker than this. Here it is total 2I, here only in the partial beam it is 2I. So now the deflection here, delta of this will be lesser than delta of this blue one, because this is stronger. But this delta will be greater than delta of this. Okay, so I will find out the answer between 1 by 3 and 1 by 6. PL cube by EI, and I will find the answer 1 by 3 and 1 by 6. Have you got it? Have you got it, guys? Okay. Now in this is a simple question, guys. A cantilever beam of length L. A cantilever beam of length L is subjected to movement M at the free end. The moment of inertia of the beam cross section about the neutral axis I. Okay, Young's modulus is E. LIE. The maximum deflection is the free end, that is ML square by 2EI. The maximum deflection is at the free end, that is ML square by 2EI. Okay, this I guess all of you can do. Okay, any doubt, guys? Please tell me. Shall we move to the next question? Okay. Now moving next. I guess some of my old students have done this many times. Beautiful question, guys. Now one is the shear force V. And due to shear force, the shear stress is like this. 0 at top and bottom. And here it is maximum. That is tau max. And it is 4 by 3 of tau average. Due to this orange one. Now due to this green one, torque, it is maximum at circumference. So 5 cannot be the answer. Because 5, this is 0. So it is maximum at the circumference. Due to torque, It is maximum at the circumference, like this. Now, guys, 1 and 3, 1 cannot be the answer because 1, this due to V it is 0. 2 cannot be answer because due to V it is 0. 5 cannot be the answer because 5 due to torque it is 0. So combination will be seen na. So at 1 and 2 due to shear force V it is 0. At 5 due to torque it is 0. So combination will not be coming maximum. So either will be 3 and 4. Now, guys, out of 3 and 4, now the torque is like this. So at 4 it is downward, and from 3 it is upward. From 4 it is downward, from 4 it is downward, from 4 it is downward, and from 3 it is upward. From 4 it is downward, and from 3 it is upward. Okay, so it is like this. Tau max and tau max, both it is 16t by pi d cube. Guys, at 4, both are at the same side. Due to V it is downward, and due to torque also it is downward. At 3, due to V it is downward shear force, but due to torque it is upward. So algebraic sum will not be maximum. So answer will be 4. Answer will be 4. Have you got this beautiful question, guys? 5-star question here. My stars are looking like a triangle. Triangle and some angle bisector. Have you got this? Any doubt? Yes, thank you, Mohit. Thank you. Guys, tomorrow Sunday ka funda. The bridge collapse video from directly I'll be live from Uttarakhand. Okay. So watch that, guys. Now a prismatic shaft fixed at A and B. This is A and this is B. It is fixed at A and B. It is fixed at A and B with intensity 0 at A to T0 kilonewton meter at B. Zero at A, and here it is T0 kilonewton meter per meter at B. Guys, not 1, 2, 3, 4, 5 torques are not acting. Infinite torques are acting with this intensity. What is the reaction at A and B? Same like SFD BMD, guys. What is the total load? This area is the total load, na? This area is the total load. Area of the loading diagram is the total load. What is the area? Half base into height, T half L into T naught. T naught L by 2. Total load is this, and this will be acting at center of mass. So total load is T naught L by 2 area, and this is acting at center of mass. So 2L by 3 from here and L by 3 from here, and now we know the standard result, this standard result. Now we know the standard result. Like T here, A here, B here. So here the reaction is TB upon A plus B, and here the reaction is TA upon A plus B. Now, in this question, guys, the torque A, reaction at A, total, this formula, standard result, T naught L by 2 into L by 3 by L. So it is how much? T naught L by 6. T naught L by 6. Okay, and there TB, it is T naught L by 2 into 2L by 3 by L. So here it is T naught L by 3. So reaction at A is this, B is this. Of course, at B there is more torque. So reaction at B will be more. Okay, guys, this is a formula memo test, scholarship test. I already told you this is my workshop that will be coming on 1st November, Wednesday. The blueprint, the free workshop, guys, on app. This will be there, and mega mock challenge is there. Sunday ka funda tomorrow. I'll be coming. This I already told you. Now Dheeraj sir will be coming with next question, guys. Over to Dheeraj sir now.
Yes. So, guys, now we are going to see the next question. This is once again from deflection. So you can see they are saying match list 1, list 2 and select the correct answer. Central deflection in a fixed beam subjected to UDL. Central deflection of a simply supported beam subjected to UDL. Central deflection in a simply supported beam subjected to concentrated point load. Deflection at the free end of a cantilever. I feel everybody would be knowing about the formula for this. This is W. Okay. And this is central deflection for simply supported beam subjected to point load. So here, my dear, you can consider that point load is equals to W. Okay. And here when they are taking this UDL, then this entire UDL W into L is written as W here. So keeping that in mind, you can answer which is going to be the correct answer. Yes, Mohit, Arvind, tell me what would be the answer. And I would like to tell you guys, yes, okay, Papa Ghoda is saying A. Okay, if you are saying A, let us see. So first of all, you are aware about the D option. For this case, if this is W, what will be deflection? It will be WL cube upon 3EI. Okay, I feel this would be known to you. So you can see this is first option. So S is going to be connected with first. If you just see that now, then you will say A cannot be the answer, C cannot be the answer. So I have used the lifeline of 50-50 for you. Now answer can be either B or D. So I have used 50-50 lifeline for you. Now tell me what would be the answer. Okay. Yes, Arvind. So PL cube upon 3EI is mentioned here. So this is going to be the answer of S. So S and 1 are considered. So either answer can be B or D. A and C cannot be the answer. Now, my dear, there is one more case about this. Simply supported beam. If you are talking about a point load here, then I feel for that also you would be remembering WL cube upon 48EI. This is the standard table you need to remember. So WL cube upon 48EI is this one. So central deflection because of UDL, because of point load. So R is connected with 2. So R is connected with 2. So these are both can be correct till now. Then my dear, we are going to see the next thing. The next is if we are having a simply supported beam which is subjected to UDL. So because of UDL, you know the central deflection is WL. Actually, if this is W, then WL4 upon 5WL4 upon 384EI. But they have taken this W into L as equals to W. So if you will consider this, it will be 5WL cube upon 384EI. So Q will be connected with 3. So for that reason, I can say the answer is D. Okay, so it shows that you guys are not having reminder of remembering these formulas. Try to remind these or remember these formulas. Okay, so the answer for this is going to be what? D. Okay, guys, moving to one easy question now. Which of the following relation is correct? dV by dx is equals to m. dw by dx is equals to v. dm by dx is equals to m. dy by dx is equals to theta. Okay, actually this is v. So you need to tell out of these four which of the relations are correct. This is shear force, V is shear force, M is bending moment. Okay, M is bending moment. So my dear, this is also MSQ. So more than one can be correct. सोच समझ के answer करिए. I am feeling कि many of you guys are giving wrong answers. So Hari is saying the answer is C. Arvind is saying the answer is D. This is MSQ. More than one can be correct. Mohit is saying the answer is B. Very good. Mohit is saying B and D. So the answer is B and D. Because my dear, I am telling you all the relations now. When we are going to write V, dV by dx is equals to Wxx. Second is dm by dx. It is Vxx. Okay, these are two relations of SFD, BMD. Then my dear, when we are talking about d theta by dx, it will be Mxx. Then dy by dx, it will be theta. So guys, always remember that load, then shear force, then bending moment, then slope, then deflection. They are in increasing power of x. If it is x ki power n, it will be x ki power n plus 1. It will be x ki power n plus 2. It will be x ki power n plus 3. It will be x ki power n plus 4. Clear for everyone? So guys, this is what you are going to use, and B and D are going to be the right answer for this. So guys, here we are completing the session. Yes, very good, Akash. So these are the questions. Hope you enjoyed these questions. So guys, I would also like to tell you that this series is going on. I will be coming up for a session for theory of machines plus machine design plus production. Like this, I will be having the questions related to formulas. So be ready for that session as well. And goodbye for this particular session. And guys, those who have filled the form of BARC technical officer exam, admit cards are released. Okay. So you can download that. Okay. And already sir told you that tomorrow will be the Sunday ka funda. So you can also join that. And as you know, every time whenever sir is going to the site, and then you are getting the real time feeling of that. So you can definitely enjoy that session. So goodbye guys for this particular session. We'll meet again. Goodbye.